Okay, we're back. I'm still on the February 1st Zoom meeting, part 3. Wi-Fi kicked me out in the middle of this, so I had to record and upload that. And now I'm back. This is part 3. I don't know how many parts this is going to take, but I am determined to finish. So I'll go until it kicks me out again or something happens. All right, so we were trying to explain the minimum 75% of the data will lie, according to Chebyshev, within 2 standard deviations of the mean, and at least 88.9% of the data will lie, minimum of the data will lie within 3 standard deviations of the mean. Sometimes they have you do a strange number like 2.5 standard deviations. Deviations of the mean. So let's say within 2.5 standard deviations, what percent? So again, you have 2 is 75%, 3 at 88.9%. You can see 2.5 would lie here. Your percentage formula, 1 minus 1 over k squared, 1 minus 1 over 2.5 squared. One minus 1 divided by 2.5 squared, 84%. You can see it's between 75 and 88.9. That would be minimum 84% of the data lie within 2.5 standard deviations of the mean. We'll work an example Chebyshev. In fact, maybe I should go ahead and work it now. Let's see. I'll tell you what, instead of going back and losing my camera, well, I don't know. Let's see if I can do it. Let's see if I can do it. Let's see if I can pick one off the Chebyshev. So I'm going to new share, and I'm going to screen. Actually, they were telling me this doesn't put the thing on your, let's see. Let's see if you're back to the camera. I think you got to stop share and go to screen. And let's see if I can find a study plan here. Yeah. And so let's try Chebyshev 3.2.35. This is off MyLab Statistics, just to show you the kind of stuff they'll have you do with this. MyLab Statistics. This is 3.2.35. All right, at one point, the average price of regular unleaded gasoline was 3.67 a gallon, so I'll write that down. Assuming standard deviation, we'll use S for that, is 0.04. And use Chebyshev's inequality to answer the following. A, what, I'll write these down, within 3 deviations of the mean. B, what percent within, I just did 2.5, what percent within 2.5 standard deviations of the mean. Mean, what are the prices within 2.5 standard deviations of the mean, And part C, minimum percent of stations with prices between 59 and 3.75. Okay, I can't really show you how to work these on this screen. I'll kind of work them under the camera for you, and then you can enter the numbers back here. Let's see if I can get back to the camera. Once you see it done, you realize it isn't hard. Just a matter of knowing your Chebyshev table. Okay, back to the camera. All right, so I didn't write down all those words, a lot of words. So there was the mean, there was the standard deviation. First question, what percent within 3 standard deviations of the mean? Might have said minimum percentage. All right, well, I'll redraw the Chebyshev table. This is the Chebyshev table. I use 2, 3, remember 75, 88.9. And there you are, 88.9%. Right off the Chebyshev table. It's that easy. Some of these are that easy. Now, what percent are within 2.5? All right, well, I did that on the previous page. I can do it again for you. 1 minus 1 over 2.5 squared. Remember that came out 84% on the previous page. You can punch it. So 84% are within 2.5. Now, what are the prices within 2.5? So that's where you've got to draw out a statistical number line. Mean in the center, that's your 3.67. And then you want to be 2.5 standard deviations up, which means 2.5 times 0.04, and down times 0.04. This is an S. That's a 5. So this number is going to be 3.67 add 2.5 times 0.04. 2.5 standard deviation. So 2.5 times the standard deviation, but added to the mean. $3.77. And all you got to do to get the other side is just change the plus to minus. $3.57. So answer here, 57 to 3.77. I'll leave it to you to enter that in my lab. And hopefully I won't look like an idiot. So now this is C is the reverse problem. For the mean, you've got 3.67. Down here, you've got 3.59. And up here, you got 3.75. They want to know the minimum percentage of stations between that. Find minimum percentage. Well, you're going to have to find, you must find K. And there's formulas for it, but I can't show them to you right now until we hit 3, 4. So right now, we're just going to do it on our fingers or by adding. In other words, standard deviation, remember, is 0.04. So if I go plus 0.04, add it once, I'm at 1 standard deviation. That would be 3.71. If I add 0.04 again, can you tell that will equal my 3.75? 2 standard deviations. This is at 2 standard deviations. This will be at 2 down. I don't really have to check it. They usually give you a symmetric interval. So K equals 2. Minimum percentage, 75 from the Chebyshev table. From the table. I'll let y'all play with those. I think there's one other. Let's see, here it is. I think there's 3.2.36. I'll let you mess with that one. All right, now we're ready for the empirical rule. We are going to get to an end of this. Trust me, there's a lot of stuff. Second scheme. Remember, the question is what percent of the data lie the K equal 1, 2, 3 intervals. Second scheme called empirical rule. You make a table. Very cleverly named empirical rule table. It will have all 3 numbers in it, 1, 2, and 3. The formula for it comes from calculus. And this applies to a bell curve. Empirical rule, it's for a bell curve. From calculus. %, 95%, 99.7%. Again, 68% of the data within 1 standard deviation on a bell curve, 95% within 2, 99.7% within 3 on a bell curve. For a bell curve. You can actually picture this. You can have 1 standard deviation and -1, and there'll be 68% of the numbers within 1 standard deviation. Go out to 2 standard deviations. You're up to 95% of the numbers within 2. You can calculate this from calculus. 3 standard deviations, -3, 99.7% of the numbers are within 3 standard deviations of the mean on a bell curve. Can't show you the formula. We don't do calculus. You just have to believe it. Okay. Why don't we, instead of me going back and showing you, why don't we show, well, I may have to get the exact formula, but why don't we, for an example, MyLab 3.2.4. That's the first one under empirical rule. Okay, let me stop the share. And we'll go back. Let's see if I can... empirical rule 3.2.4. I want to go to the next page. True or false? Chebyshev's inequality applies to all distributions regardless of shape. but the empirical rule holds only for distributions that are bell-shaped. That is true. I'll let y'all enter it. Let's try the next one. Let's see, try one with a little math in it. Sample variance of standard deviation. Okay. 3.2.5. Okay, well, they're kind of doing these kind of in order. Let me try. All right, let's try 3.2.23. Okay, that is actually I was a little long on y'all. So I jumped to 3.2.29. Let's see if that was a little more reasonable. This one's pretty long. Oh, you can't see the camera. Okay, let's try 3.2.29. Here we are. Okay, here's one with a little bit of math in it, but it's much more reasonable. Okay, we have a bell-shaped 3.2.29. Bell-shaped. Mean is 100. Standard deviation equals 13. Use empirical rule. Okay, 1, 2, and 3. 68, 95, 99.7. Part A. What percent people IQ between 61 and 139? All right, once again, we've got to set up 100 in the middle. And I would build out the statistical number line. Okay, and you can't see my camera. Stop the share. And boom, you can't see my camera. Okay, here we are. So I've recopied it. They don't give you the table, empirical rule. So I wrote the table out, and this is the question they're asked in 3.2.29. Between 61 and 139. I didn't get the other two parts. Maybe if you get this one, you'll get the rest of it. So I would just build it out. Your standard deviation equals 13. So if I go plus 13, one standard deviation, I'd be at 113. I haven't hit 139. So it's not a 1. If I add 13 again, I'm at 126. That would be 2 standard deviations. Still haven't hit 139. So if I go out to 3 standard deviations plus another 13 again, there's my 139. This is a K equal 3 interval, percent, 99.7. That's the kind of things they have you do with these kind of problems. Instead of me going back to B and C, I'll let y'all mess with it. Let me show you like 3.2.3, the kind of stuff that they have you do. One last example. Very first homework in my lab, 3.2.3. This is the kind of tricks they show you. Let me get back and show you the problem. Let's see if I can find it. 3.2.3. No, dadgum. Let's make it 3.2.5. Okay, let's see this. Okay, find is 20, the date is 20, 10, 4, 8, and 11. Find sample variance and standard deviation. They give you a choice of A, sigma squared, and B, S squared. They give you blocks where you enter your answer. All right, if you watch the first video, this is sample. So you're going to not enter anything here. And you can't see my paper. Got to get back to the, okay, got to get back to the, okay, here we are, 3.2.5, the data there, find sample variance and standard deviation. Okay, the first answer they want, notice the squares. This answer is sample variance. This is population variance. Okay, you're not going to enter anything there. If you do, I did just see what would happen and give you the error. Wrong, give you red X, wrong. You're not supposed to enter anything there. Okay, now, if you watch the first video, I showed you how to go to stat mode, stat, edit. You go up, highlight the top, clear and down, flushes the column, 20, 10, 4, 8, and 11. You can enter the numbers. Stat, calc, one variable stats, enter. Okay, remember we want a sample number, S. We get off the calculator, we get SX equals 5.899. That is the average distance of each of these numbers from the mean. The mean happens to be 10.6, but they didn't ask for it. Average distance of each of these numbers from 10.6. Now, that is not the number you enter here because they want it squared. The variance is S squared, 5.899 squared. 5.899 squared, 34.798. Now, I think they have directions to round it to one place. So you can experiment. I don't know how picky they are about their place, but that is what would go there. All right, I won't go back to the other screen, but I assume on the next screen, they'll probably ask for just the S, in which case that would be this. I hope this is as clear as Lake Lanier. That's about all I can say about these problems on my first cut. All I can do is really let you go at it. And on Thursday in either Zoom session, you can tell me, ask any questions, see if you got any problems with this. It's a lot of material. I appreciate your patience if you actually watch all 3 videos. But we'll end this part 3. And this is that's basically all the material for both of these sections, 3.1 and 3.2. Thank you for your patience.